Hello guys, this is Ray, and I'm doing something a little different today. It's kind of a tutorial. And what we have here is a Nethervator. You take a look, you notice I am at Y5, so pretty much bedrock level. So what we're gonna demonstrate is you can take a nether portal into the nether, step through an adjacent nether portal as soon as it goes through, and end up at the top of the world. Well, as close to the top as we can get. I could probably go a little bit higher, but Y121, that's not bad. 116 blocks. Now, there is a science to this, or I should say math to it. So I'm going to go, you have to actually go really far away if you want to build another set of portals. So I'm going to go really far away, and I'm going to be right back with you guys and make another one. Alright, we are way far away from our previous portals, and I already made the platform up in the sky. You can kind of see it at an angle up there at the top. But basically, you need to find the sites for your other overworld portals. And note, you remember the portals, they have a 2 wide gate thing. And that's going to be important because the way the math works on this is when it's looking for a portal, it doesn't look for the base. It looks for the portal block on top of the obsidian. So find the one that is the smallest number, which would be this one right here. And then you look at your coordinates. Now, on these coordinates, they are what you call floored, which means rounded down. Now, it doesn't exactly, at first guess, look like what you would think rounded down. And I picked these coordinates for a reason, because one of them has a negative in it. The x actually would round down to negative 80. So you're going to need to write down the coordinates of your portal. So you got negative 80, 5, and 400. And then if you want, you can go ahead and build the portal. Now, you need that block, not this one. And I also noticed that those numbers were nice and even. They can be divided by 8. I only did that for demonstration purposes. You can actually make them wherever you want. Just make sure you take the smallest. Now, for the second portal, based on how the math is done, I recommend on the overworld making it at least 32 blocks away from the first portal. Not height-wise, just length-wise. And that's if you're spanning the whole world. If you're actually a little bit closer, you can go a little bit. If you're actually not going as tall, you can go a little bit closer. But I don't recommend just a one space because sometimes that can have problems. But I've already built this up here. I built a little platform. I think I might have, I built it up all the way up here. And you're going to do the same thing with this portal. You're going to mark its coordinates, which this is going to be that block. And we're also going to be at x is negative 80, y is at 121, excuse me, and z is going to be at 360 in this case. So yeah, you can go ahead and make this portal as well. I'm in creative because I'm just showing this off. And go ahead and give it a light. I probably should have lit the other one while I was down there, but we'll just do it this way. Yay for creative mode. Alright. Now I kind of like to block off the back like you were walking through, and so that way it comes out the other end. But this part's not necessary. This is just something I like to do. Alright. Then you step through one of the portals. It doesn't really matter which one you step through. And we'll be right back as soon as my nether generates. Alright guys, we're in our nether. It actually didn't put me out that far from the other place. It actually put me to the other portals that I had because it was really close in coordinates. That's the one thing about this is you can sometimes accidentally link up to other nearby portals in the nether. So you got to be careful with that. But anyway, back to what I was talking about. Now you look at the coordinates that you wrote down earlier. Now for your x and z values, it's pretty easy. You just divide by 8. You divide by 8 and then floor the value. Now if you're going the other way, you'd multiply by 8. So for the first portal, we're going to get x of -10 and z of 50. Now, the important part of this is the y coordinate. And the reason being is because the way that the game searches for portals. So to find your y coordinate, you take the y of the upper gate, which in this case was 121. I said the wrong number last time. And the y of the lower gate. You subtract them, which gives you 116. And then you take this and divide it by 2, which gives us a y of 58. Now you're definitely going to want to get an even number that divides evenly. It just makes this a lot easier. It keeps it from glitching out. So you're going to build the first gate, and you're going to look for that leftmost portal point at those coordinates that I just mentioned. So here's that y58, and you're going to want -10, and remember it's floored. So this wouldn't be -10, that'd be -11. This would be -10 right there. And then you're also going to want 50. So we're actually going to fly out about this way. It looks like it's going to be directly over lava. How fun. Alright, 2 more. This would be a pain to do in normal mode. Alright, so -10, 58, and 50. So we're going to place our block there. We're going to make the portal. Sorry if I'm the slowest portal maker ever. Alright, give it a little room where you can walk in and out. Alright, now you're going to do this. Whoop. Now you're going to do the same thing for the other gate. So that gives us coordinates of x -10, y at 58, and that's important. Well, both the y's are going to be equal. And then z of 45. So we're going to move back in, and it should be right here. Not really that far apart inside the nether. Alright, so -10, 58, and 45. That's going to be those leftmost coordinates. Now, once you've got these built, you can actually go ahead and light both of them. Just don't step through them until both of them are built. Alright, I'm going to put our little back on over here. Yay, lava. I don't know why it's been doing that, making me fall without me actually touching anything. A little bit of a lag spike there. Nothing to worry about. Alright, so there's our Nethervator. Again, that y coordinate and getting those lined up exactly where they're supposed to be is very, very important, because the math is so tight that just a little bit off can cause it to link to both of them to the same gate, possibly. So the one with the greater was our lower end. So we're going to go through this one. We should end up on the ground. Let's go test that. And look, we're on the ground. And this is the gate that I built, because it has these grass blocks around it. So when we go up there, there shouldn't be anything behind the other one. So we're going to go back through. It should bring us back through our portal to our nether gate elevator. Oh, yeah, that's where we're supposed to be. And then walk through, and we should be up top. And there we are. And it doesn't bring me to the other gate because you can see through the back, because I put it back on the other one. So, there you have it, guys. We're going to go down and look at that grass block just to show you. There you have it. A two-way Nethervator. Just to prove the two-way. Go back through the other direction. I shouldn't have fallen down, should I? Now, unfortunately, you may have noticed that I didn't go any higher than Y128. That's actually the cap on this right now. There's actually a bug with the new format that the portals do not look any higher than Y128 when they're searching for a matching portal. So if you can build one that high, and it will most certainly bring you to a gate in the other world, but when you go back through, you will not end up in the same place because it won't connect to it. There you go, a two-way Nethervator. Stay tuned if you want to see how the math behind why this works. Okay guys, as promised, the math behind why this works. To do this, we're going to use a little bit of trigonometry and some planar geometry. Now, planar geometry also can be used for, instead you could also use vector algebra, but it's a little easier to explain. So what we know, the way this works, the coordinate system, we already discussed that, it floors everything. What we know from planar algebra and stuff, we'll go over that when we hit that. But basically what we know is when a portal is linking to its counterpart, either at overworld to nether. First thing we know is that to go from one to the other, if you're going from the overworld to the nether, you are going to divide the x and the z coordinate by 8. Floor the value afterwards as well, and that will be where it starts looking for a portal. And then when it looks in 128 block radius centered on where you entered the portal. So that's why you needed those coordinates where the portal was. Now, it also works the other way, coming from the nether to the overworld. But instead of dividing by 8, we multiply by 8. So that's why the height is very important. And we'll go over that why in just a second. So to start off, we have our two portals. The overworld portal and the underworld portal. We're going to call the bottom one portal A, and the top one we're going to call portal B. Now what we want is to link to portals in the nether. We want to link to portal A to portal 1, and then we also want to link portal 2 to portal B. Now the letter ones are going to be in the overworld, and the numbers are in the nether itself. Now, you go through portal A, and it looks for a counterpart in the nether. And right now, when we set it up, it's gonna find portal 1 and portal 2, and the distance between those we're gonna call A1 and A2. The same thing happens when you come back through the nether. It looks for matching portals, and it's going to find portal A and B. We'll call those distances. We have A1 already, but we're gonna call the other one B1. Same thing goes with B, B1 and 2. Now, we have a third distance, distance 1 through 2, and that is the distance between both of the nether portals. Now technically we have another distance, that's the distance between portal A and B, but for the reasons of this explanation, we don't really need that. So, what can we get from this information? Well, first things first is we bring in our planar algebra. Now, I use planar algebra because, well, let's face it, Minecraft is a 3D game. And in order to prove this for all combinations using the method that we used, we need to know a few things from planar algebra. Now, given in planar algebra, you have 3 planes. You have the plane for the x-axis, the plane for the y, and the plane for the z-axis. Now, by definition, all 3 of these planes are perpendicular to each other. That is, whenever they intersect, they form right angles. So, this distance 1, 2 is actually part of the x-plane. And planar algebra states that whenever if it's part of a plane that intersects another plane, and those 2 planes are perpendicular, then that line is also perpendicular to that plane. Now, since we know that 1, 2 is part of plane X, and we look at B2 and A1, and we know that those are also part of a plane, in this case plane Y, which also intersects with X. So, since both of them are in planes that are perpendicular to each other, and they intersect, then that makes the lines perpendicular to each other, which gives us these right angles, as you see in the picture. And that's important. The next thing we know, we want to make sure that these distances, B1 and A2, are going to be longer when it's looking for the matching portals. So, what we know is since we have that right angle, we know that we have a right triangle formed by the 3 pieces. and that opposite side is called the hypotenuse, and that will always be the longest piece of the right triangle, will be the hypotenuse. But how do we prove that it's going to be, because we want to match A1 and B1 and prove that A1 is longer than B1 and prove that A2 is longer than B2. Well, what we know is the distance 1, 2 is the same, obviously, because it's the same line. But the second thing we know is that A1 and B2 are equal. And the reason we know that is because when we calculated the y-coordinate to find the distance, we divided that in half. That's why it's easier to use an even number before you divide, because that guarantees that those two things are the same. So now we have 3 equal parts in each triangle. A1 is equal to B2. The right angle in each one is equal. And the line 1, 2 is equal to itself. And a property in geometry states that if two triangles with two sides and an included angle, which is the right angle in this thing, are equal, then the two triangles themselves are equal. So that means A1 or A2 and B1 are equal. So that proves our case in all things, that when they're trying to go through portal 1 and it sees portal A and B, that A1 will always be the shortest distance. So there's the math behind it. Go back over the steps briefly. You find your portals on the overworld and record their coordinates. Make sure that the distance, not the straight up and down, but the as the bird flies to where the portal will be, say around 32 blocks in difference. Then in the nether, you find the x and z coordinates for each respective portal by dividing by 8. And make sure you floor the values. It means round down. Don't just chop off the end, round down. And to find the y coordinates, you subtract the y coordinates of each portal in the overworld and divide that by 2. And then when you have all the portals lit up, they should link. Well, I hope you guys enjoyed this tutorial slash math lesson, I guess you could call it. And feel free to leave any comments in the bottom. Let me know how I did. This is the first time I've ever done a tutorial, so I hope I didn't bore you to death. But yeah, I'll see you guys next time. Thanks.